Here we have a link traverse between A and E, going through stations B, C, and D. What is given? We have the azimuth of the first line, which is azimuth AB as given here. It is alpha AB, and the amount is 992240. At the end, we have the azimuth of the line ED. Also, we have it in this direction. We have ED, and the amount of alpha ED is 265.1757.6. What is given also is that the summation of angles B and C, they are 327.05 and 00 seconds. What is required is to find the amount of the angle D, assuming that we do not have any angular misclosures, so everything is fine. So as if alpha AB is good, 327.05 is good, no misclosures, and alpha ED is good, no misclosures. How are we going to solve for this? We are given the azimuth of the first line, azimuth of the last line, and we have the angles inside. Two of them, we know their summation, and one of them, which is D, that we need to evaluate its value. So we will use the formula that we found to calculate earlier in the chapter, to calculate the azimuth of the last line. So we said it is the azimuth of the last line here equals the azimuth of the first line plus the summation of the measured angles. Why the summation? We'll let you know now. And minus n minus 1 multiplied by 180 for the extra revolutions that we might be doing. So why is it plus? Because we are saying these are clockwise angles. Clockwise angles B and C and D. Why are these angles they are clockwise? Because we start from here, from point A, and then we will be going in this direction, all right? So from the known, this is known azimuth, to the unknown azimuth. Here we are going through this angle, so from the known to the unknown, we will have a clockwise angle through this specific angle. The same thing here, we will go from after we take, if we find this azimuth, we'll take its opposite, which is back azimuth, and then we'll be going from it to the other one. So it will be known here, unknown here, so we will be going clockwise. To apply this formula, we have to have the azimuth of the first line in this direction from the inside station to the outside station, and the result, the calculated azimuth, will be from point D to point E. What we have, we are given, it is alpha ED for the last line and alpha AB for the starting line. All what we need to do is to calculate the back azimuth. So if you have alpha BA, it is the back azimuth, equals alpha AB, which is the one that is given, alpha AB, and looking at the value is 99. So to calculate the back azimuth of the line AB, which is alpha BA, equals the forward azimuth alpha AB, since the value of the azimuth is 99, which is less than 180, so we have to add 180. On the other side, we have alpha ED, and to calculate alpha DE, which is the back azimuth, we will in this case subtract 180, because alpha ED is given as 265.1757, which is more than 180, so we subtract 180. At the end, we are now having alpha DE here from inside to the outside, and we have alpha BA from the inside to the outside, all right? And we are ready to apply the formula. What is in the formula? So what is here we calculated the last line. The last line from inside to the outside is 85. So we put it as the alpha here. So this is the value. This is the value of this. Okay. So it is 85, 1755.6. Now equals to the alpha of the first course. The first course, or also it is from the inside to the outside, and here we calculated that alpha BA equals 279. So we put 279. And then summation of the measured angles. So what do we have? We have this angle, B, C, and D. So this is B, C, and D. We'll come to the values later. Minus n, it is 3 angles. Minus 1, it is 2 multiplied by 180. And then we come to the angle substitution. This is what we have, the last line. This is the first or starting line. And here we know B and C, we are given that they are 327,050 seconds, plus D. D is the unknown. Minus 3 minus 1 multiplied by 180 degrees. So at the end, in this equation, we have only D as the unknown. Rearrange, do the calculations, and D is 198 degrees, 50 minutes and 17 seconds. And that's it.